I'm Mark, one of the technical team here at StoreMagic. And what I'm going to do as part of this, or as this video, is to take us through a very quick couple of slides and then give a bit of an overview of our new SvHCI solution stack, a bit of a journey through StoreMagic, as it were. Now, we as an organization have been doing very well for the last many years with our SvSAM product. That was effectively this guy, a storage controller virtual machine, a VSA, and that then ran on top of hypervisor. So like this, effectively one on top of the other. Now it was there providing resilient SAN storage, block storage, simple storage, and served a fantastic variety of use cases from SCADA systems to enterprise robo with 6,200 locations under one customer, for example, to SMB and SME, to video management solutions, to ERP systems, anything you like. Simple block storage at the end of the day. Okay. Now we can see here that I'm using, or I have as this slide, at least some very lightweight systems. We'd go all the way up to things like Apollo and Electra, S3260s in a Cisco world, C240s, Dell R750s, 1U, 2U rack boxes, tower boxes, small form factor boxes. Our big value proposition was around sort of flexibility and sizing for the appropriate use case, as it were. Now we can see with these systems, and these are going to be the sort of lab systems that I show you in just a second, small and lightweight. But what we traditionally were was this controller virtual machine on top of the hypervisor. So effectively sitting on some local storage, own those disks. We'd make them, using our software RAID internally resilient, so one fault domain, and then cross-node resilient, so another fault domain, and effectively then go, here you go, hypervisor, have a disk. Would then be a VMFS, that would be a CSVFS, and those virtual machines then living on top of it. And we've got, many customers from 400 plus sites of 2-node Hyper-V to 6,200 sites of 2-node VMware to whatever you like. Simple, high availability, 2-node, lean, lightweight, etc., etc. Okay. Now, obviously, what happened then was Broadcom came in and turned the world upside down. And with that, then we've had various customers coming to us and saying, hey, we love your technology. It's been as rock solid as it can be. It's fantastic. Can you help us? And obviously we wanted to be able to do that. So what we've effectively done is to, inside here is effectively a Linux distribution, a Linux OS, standard kernel. I think it's 5.14 something with the current release, 5.15 maybe, that we forward rev, we support. And it's a closed appliance. It's a closed system, i.e., secure, can't be, SSH'd into, hacked into, messed about with. It's a secure appliance model. Okay. So what we did with that was to effectively integrate Commute, KVM, and Open vSwitch inside this thing. So rather than like other vendors going, hey, we've started with a hypervisor and we'll crowbar some storage in there, we've started with storage, serving I/O, obviously one of the more complicated things, and we're adding in the compute to it. And rather than sort of trying to cobble those bits together, separate from each other and things like that, it's all then in this tightly integrated, secure system that we can then support. Okay. And that effectively becomes SvHCI. So within there, that Linux OS, that build image that we produce and we support, is then running bare metal on the servers. So that can be per HCL, then HP, Lenovo, Dell, Supermicro. You can put your Windows and your Linux guest OSs up on top as you want to. You can run containers inside those guest OSs, of course you can. And it's also then a sort of fast, efficient failover. Okay, now we're seeing here then 20 seconds. I'll prove that out in just a second. And we inherit a bunch of functionality from it being SvSAN effectively. So like caching, like data arrest encryption, like that software RAID functionality to be able to provide the resilient topology. So it's basically architected to be a simple, easy, high availability solution. Start with a single node, convert to a dual node, break a dual node to a single node if you were doing a staggered node swap, for example, due to a critical issue. And of course, then, backup being an agent-based backup, provided by whatever backup vendor you provide within those guest VMs. We will be adding additional functionality to it in the realm of snapshot with future releases, but we wanted to get something out quickly and available for customers to utilize and leverage. And being that it's our technology, we're not sort of integrating with something open source or some other vendor, it's all then fully supported by StoreMagic. So our technical services team, fantastic CSAT scores, G2 scores, all that good stuff. And we provide all the drivers, we support that hypervisor stack. So from a customer perspective, it's all web GUI managed, it's all API managed. And that then reduces that attack surface down significantly from a security perspective and from a supportability perspective. So let's get on with some real systems and actually show something if we can do. So here what I have, let me just zoom into that a little bit, an example of one of our sort of VMware Robo setups, as it were. So within VMware today, we have our plugin. This is a plugin virtual machine that would live alongside the vCenter. Could all be on top of the cluster, but in my scenario, it's sitting remote up in like a data center, as it were, somewhere separate to manage those edge locations, as it were. Now, the plugin allows you to deploy out those appliances, provision out your storage, and do all your good stuff there. And we can see that Site 1 Shared 1, if I come over to this guy here and go here, we can then see Site 4 Shared 1. So it's a granular management process, or it's per data center, such that I don't get a wealth of information. So it's all architected for scale, for large scale environments. And we've got, 1,000 sites of gas stations. We've got 2,500 sites of, big box retail store. We've got various grocery chains. We've got all these different things. And the nice thing with this is you've got vCenter and you've got this plugin architecture and you've got this single sort of pane of glass management process to it. So the plugin provides per location, and we can then see our dashboard up on the main vCenter that then gives you all VSAs then sort of managed by that vCenter. So obviously less information, but an en masse view that we can then come along and get some status type information on different things. Now, if I select one of these VSAs, we can take a look at this guy. We can go edit settings. We can see that it's a boot disk. It's really lightweight, 1 CPU, 1 memory, 1 gig of memory, and this 20 gig scratch partition. It's all fully editable. And if I open up its console, I've got a sort of basic versus interface into this thing to be able to manage it. Now, if I come over to here and just grab one of those nested ESXi hosts, we can see VMware console. So a very similar sort of concept between the VSA and that ESXi node. Now on the VSA, I then get a web page. This is akin to your ESXi host client, and we can see sort of various bits of functionality. Let me just remove that debug, forgive me. But we can see then, the architecture, the dual boot image, the networking, the good stuff that makes up that StoreMagic node, and we can see sort of various statistics as far as what that is going on that system. So we've got a little bit of write, a little bit of read going on, some actual systems and events and everything else. So that's SvSAM. And as I say, what we've done is to effectively then integrate those virtualization pieces into our VSA. And if I now come over to that hardware that I was just showing you, these are those edge lines, and open up the console, we'll now be able to see that same console view, StoreMagic SvHCI here versus StoreMagic SvSAN here. It's the same build image, just with a sort of different personality type on it. And we can see there's some additional options here. So we've got virtual switches, we've got port groups, we've got all that good stuff to be able to sort of administer that node, as it were. Okay. So SvHCI running bare metal. So in order to do this, what we're actually doing is pulling the ISO from StoreMagic, mounted up to your ILO, your iDRAC, your XCC, your IPMI, whatever you're doing, and run through a basic installation process, as it were. Now, what that installation process is doing is effectively select your disk to deploy to. Now, it could be just a single RAID disk, that would be fully supported, all on the one sort of volume, as it were. Or you can have separate boot storage to your SAN storage. Pick your pick. Okay. Now, in my systems, I've got that separate boot storage. So I deployed to my 512 gig boot disk that you can see here. Let's go down here. And then I've got these 3.84 terabytes as the Samsungs that we're using as our SAN storage. We also then deployed or we also set a static IP address, forgive me. And what that enabled was to then connect up to the node and run through a basic sort of first boot wizard, license the box, things like that. Okay. And just to reference, again, forgive me, pulling things off to the other monitor, all of that as far as documentation is fully publicly available on our portal here, StoreMagic SvHCI, that we can then come through and run through. So from installation to console to first boot wizards to some networking examples and so on and so forth. Okay, so there's a nice sort of chunk of documentation there for review. So having got it deployed and connected, what we then first do is to come over to our networking and provision out some vSwitches. So LAN vSwitch is provisioned out by default. Let's just actually delete that guy. That's Heidi, sorry, giving my lab stuff. So your LAN vSwitch created by default, and as you can see here, I've got that Mellanox NIC driver. If I come over to the VSA, same view, I just have a VMXNet3 driver where it's running in a virtual machine. Okay. But I have then a sort of front-end LAN vSwitch and a vSwitch 1 that I'm using for my storage traffic. So think like a front-end management virtual machine network and then a infrastructure network. Now this is used for my data synchronization and everything else. And out here, I'm then, my virtual machine's coming out, but I'm also talking to my witness for the quorum piece as well. Okay. So I have my port groups, my vSwitches, and I have the interfaces. Think of these akin to that VM kernel port in VMware that allows you to, set up your live migration and all that good stuff as well. Okay. Now, provisioning additional port groups, nice and easy. Demo VLAN 20, for example, set it into an access mode. You can do all your microsegmentation VLAN tagging for your port groups. NIC teaming on a virtual switch. We can do an active backup. We just check against the different NIC group NIC cards, and we can then team those networks, those physical NICs together. So having set up the networking, what we then do is to effectively cluster them together. So under here, you'd get this join option. You specify the two edgeline nodes, in my case, the two SvHCI nodes, and your witness, and you go join. And they effectively then become a cluster, as you can see here. Okay, so similar to SvSAN, it's exactly the same witness as SvSAN, the two nodes and our witness. So that means then 3,000 milliseconds of latency tolerated, 9 kilobits per second of bandwidth, and 1 to 1,000 plus locations. That witness could live in the cloud. It can sit behind network address translation. It can live in the data center. It can live on a switch in the guest shell. It can live on a Raspberry Pi. So as flexible as possible to be from a witness connectivity perspective. So having clustered them together, we can then take a look at the architecture that we've got effectively. So under my system tab, we can see my dual boot, such that upgrading these things is simply a migrate the VMs, push the image, upgrade it, migrate the VMs, push the image, reboot it to upgrade it. That simple, non-disruptive upgrade. And obviously you've got then that backup mechanism. So it's the same architecture, the same model, RAM disk with some persistent storage, effectively. We can come over to our pools. And we can see per my previous comment that I've got this boot pool. If I didn't have any separate boot storage, that I can have everything on that one disk. Or alternatively, I can have the hypervisor on one disk and then our sort of SAN storage, as you can see here, on these separate disks. And here I have them on these two NVMEs in a software RAID 1 to provide that internal resiliency as well. I can come to my events and I can see the life history of that node, so I can get notified. Those events can be forwarded out to Syslog, to Splunk, to wherever you're looking for them to, so you get all your notifications to be able to manage and monitor this thing. Now, the other key differentiator that I just want to call out is this piece. Now, you can see some slightly different icons here, but within a VMware world, What we had was a disk given to a hypervisor and then a shared file system sitting on that disk, and the virtual machines themselves then lived in VMDKs or VHDXs on that shared file system. In order to remove the complexity of the shared file system and the quorum caveats that it introduces and everything else, the disk, the SvSAN disk, what was the SvSAN disk, is now the virtual machine disk, VMs in disks, as it were. So if we take a look here, this is my X4 down from there, block the whole way down. Okay, so the pool becomes equivalent to the VMFS, and the VMDK becomes equivalent to the SvSAN disk. So rather than going, here you go, VMware, have 10 terabytes and being stuck behind a shared file system, we now have the virtual machine. Now, why that's important is because within a VMware world, when we introduced Snapshot, it effectively means that all you get is a crash consistent VMFS, and it's an all or nothing. You can't do per virtual machine, you can't do per disk. It's an all or nothing. You're resignaturing, you're all of these different things. Suddenly, when we introduce Snapshot for SvHCI, it means that we can have the virtual machine disk, we can do it granular, and we can do it in a sensible, consumable, useful manner. Okay, so virtual machines and disks, that's going to be really powerful to us as we sort of step our way forwards. Touching on the clustering piece as well, within a VMware world, what we've effectively got is an SvSAN storage cluster and a VMware compute cluster, Hyper-V and a Windows Server Failover cluster and an SvSAN cluster. Now, that's two different clusters that work very well together. They're not actually talking to each other. Within this, there is just the SvSAN cluster that owns both. It means it's really simple, really supportable from our perspective, and also then really quick per that piece, about 20-second failover time. Okay. It also means where we're inheriting all of this stuff from SvSAN, this isn't new. Okay, we've added some additional functionality, but it's the same clustering that is tried, tested, and proven in Fortune 50 companies out there, doing its stuff in 50,000 plus, licenses and clusters and everything else. Okay, so you're not the guinea pig if you were to pick this thing up, I guess is my point now. Okay. So from a virtual machine perspective, then we can come in here and we can create a virtual machine. We can protect it. That's the equivalent of our sort of HA functionality. We can give it some memory. We can give it some CPU cores. We can give it a CD-ROM, where we could pick our Ubuntu ISO, for example. We can add a network. We're just going to add a LAN network. We can add a disk, MOVM1 disk 1. Give it 60 gig. Let's put it there. Let's put it there. Make it root disk, go add, and then apply. Okay. Apart from my naming, apologies. There we go. Now, with that guy created, and again, it's very similar to what I would call a sort of VMware-like experience. What we can do is power him on, reboot, shutdown, reset, etc. We can live migrate him around, and we can open up a VNC to him as well. Okay, so what we're now going to do is to carry out a live migrate. So it's to log into this guy here. And we can see that he's there running on 10.10.194.11. Okay, so if I come here, and we can see there our things running away, our VM responding. Now, this is the bit that you want to keep an eye on, is edge line 1. Oops, if I click the right button and hit that migrate, and the pages are on about a 10-second refresh, so it'll be doing that live migrate there across that 10 gig in the background, and we can see those pings there doing their thing as the VM migrates its way across. And over we go, edge line 2. Okay, so fully migrated over to the second node, not a packet dropped. What I now want to do is to demonstrate a HA failover. So think powering off a node from underneath the virtual machine. Okay, so what we're going to do, we're going to come here, we're going to go power, and we do press and hold. Now think of this as pulling the power cable out the back of the node. Okay, so this is all via the ILO. We'll see that start to go and pop. That has now powered off underneath. Now, if we have a look, see here with those pings, that we'll see that starting to stop responding. Okay, or stop respond. So think of this like a kernel panic. Think of this like a environment power failure with that node, something similar. Okay. Now we can see here that this is already listing as edge line 1. We can open up the console and we can see it booting up. Now, full transparency, this is a blank OS. There are applications and things in here. It's just a bog standard Ubuntu. But from my experience, a Hyper-V failover is typically about 4 minutes. A VMware failover is typically about 2.5 minutes. That was 1, 2, 3, 4, 5, 6, 7, 8 pin drops for that virtual machine to be back available again. And that is all thanks to this being a simple solution, a simple cluster, the StoreMagic cluster that's been there with SvSAN for many, many years, doing its stuff. So yeah, SvHCI, we're really excited about the product and where it's going, and would love your thoughts and feedback. If you want to reach out to us at all, beta@storemagic.com, support@storemagic.com. We're all here listening away and happy to help however we can do. Okay, so it's been a pleasure talking to you, and thanks so much for listening to me.